Okay, this program. A circuit made out of the two resistors in parallel. Equivalent resistance is 50.23 ohm. If R1 is 25 ohm, we need to find out the R2. So this is the two resistors connected in parallel. Equivalent resistance is 50.23. R1 is 25 ohm. We need to find out the R2. So the parallel connection, we write down the equation 1 by RT equal to 1 by R1 plus 1 by R2. So in this case, the R2 there is 50/33, we substitute 50/33. R1 is 25, so we substitute 25. So therefore, there 1 by 50/33 equal to 1 by 25 plus 1 by R2. Therefore, the 1 divided by 50/33, we got the 0.0652. 1 divided by 25, we got the 0.04. So the 0.0652 equal to 0.04 plus 1 by R2. So that if you want the 1 by R2, 0.0652 minus 0.04, so you got the 0.0252. So the 1 by R2 is 0.0252, R2 equal to 1 by 0.0252, you got the 39.6 ohm. So this is the answer for this problem. Okay, the next problem is a 3 resistor connected in parallel. So there are this problem, resistor R1 is 12 ohm. The current in the R1 is I1. I1 is given 5 ampere. R1 is I1 is 5 ampere given. And R2 is 20 ohm. And R3 is 10 ohm. They are connected in parallel. So there will be the 3 resistors, R1, R2, R3s. They are connected in parallel. So the current in R1 is 5 ampere, R1 will is 12 ohm. The current in R2 has to be 5, R2 is 20 ohm, and also R3 is 10 ohm. They are given. So first question is, we have to find out the equivalent resistance. Our equivalence need to find out. And also we need to find out the applied voltage V. Applied voltage we need to calculate. And current in the R2 and R3 has to be find out. So the R2 current is I2, R3 current is I3. So we have to find I2 and I3. Our equivalent need to calculate. Total voltage need to calculate. And current in the resistor R2, I2 need to be calculated. And also the current in resistor R3, I3 need to be calculated. Both is calculated. Then we also need to calculate the supply current IT. IT need to also be calculated. And also the power dissipated in each branch. P1 has to calculate, P2 has to calculate, and P3 has to be calculated. Both is calculated, and as well as the total power PT has to be calculated. So both are there we have to calculate. So that there are 3 resistors, R1 12 ohm, R2 20 ohm, and R3 10 ohms are connected in parallel. So we know the current in the resistor R1, this is a 5 ampere. We have to calculate total equivalent resistance. We need to calculate total voltage. We need to calculate current in the resistor R2 and also the current in resistor R3. We also need to calculate the power P1, P2, P3 as well as total power PT. Those things have to be calculated. So firstly, we have to find out the equivalent resistance. 3 resistors R1, R2, R3s are connected in parallel. Therefore, they are equivalent equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So this is the equation we write. So 1 divided by 1 by R1 is 1 by 12, 1 by R2 is 1 by 20, and 1 by R3 is 1 by 10. So therefore, the 1 divided by 12, so 1 is divided by 12, we got 0.833 plus 1 divided by 28 is 0.05. 1 divided by 1 is 0.1. So we got. So this is the 1 divided by 0.833. 1 divided by 12, so 0.0833. 0.0833. And 1 divided by 20, 0.05. 1 divided by 10 is a 0.1. So we add 0.0833 plus 0.05 plus 0.1. So you got 0.233. So 1 divided by 0.233. So for 4.29 ohm we got. So the resistance is 4.29 ohm. And also have to calculate the applied voltage. So that we know the current in resistor R1 is 5 ampere, R1 is 12 ohm. So the voltage V1 is equal to the I1 into R1. So I1 is 5, R1 is 12, so you got a 60 volt. This is also equal to the supply voltage V is also 60 volt. So we calculate supply voltage V is 60 volt. So the supply voltage is 60 volt. And current in R2 and R3. So therefore, all our resistors are connected in parallel. Supply voltage 60 volt is also across a R2, also across a R3. Therefore, the current in the I2 have to be calculated V divided by R2. Supply voltage 60, R2 is at 20, so you got a 3 ampere. The current in the R3 can also be calculated. I3 equal to V divided by R3. The voltage is at 60, resistor is 10, you got a 6 ampere. So I3 6 ampere, I2 3 ampere we got. And also have to calculate the supply current I total. I total is I1 plus I2 plus I3. Because of the parallel connection, supply current is the sum of the all branch currents. So the I1 value current magnitude is a 5. I2 current is 3 ampere. I3 current is 6. 5 plus 3 plus 6. You got the 14 ampere. So the supply current is a 14 ampere we got. And also need to calculate the power dissipated in the each branch. We have to calculate the power in the R1, power in the R2, and also power in the R3. So that we write down the equation. Either you can calculate use the I square R or V square R, the same formula. So the P1 equal to V square divided by R1. The voltage is a 60 square. Resistor R1 is 12. 60 square divided by 12. So you got the 300 watt. P1 equal to 300 watt. P2 and also be calculated. Voltage is at 60 square. Resistance value is at 20. 60 square divided by 20. You got the 180 watt. P3 has to be calculated. Voltage square divided by resistance. So voltage 60 square divided by resistance 10. 60 square divided by 10. You got the 360 watt. So we got. Then we also calculate total power PT. PT equal to P1 plus P2 plus P3. So in this case, our P1 value is at 300, P2 180, P3 is 360. So 300 plus 180 plus 360, you got the 841. So this is the way we calculate the all power. So in this case, this problem, we know there's a current in one branch. So firstly, we calculate the voltage across this resistor, and all resistors are connected in parallel. So the same voltage across all resistors. So this is the way we use this problem. So if you know there's a supply voltage, so then we can calculate the current in the other branch, the voltage divided by resistance. And also the power can also be calculated, voltage square divided by resistance. Then finally we add the all power together.